Okay, what we're going to do now is prove some identities, and of course we'll be using those double angle identities to help us out. Now, in most cases, on these when you're proving, and I say most because not all the time, but wherever you do have a double angle, so of course that would be anywhere that you have 2 times theta or 2 times x, that's typically where you're going to start at and do a substitution. Okay, so on this one, you look at your identities for cosine 2 theta. Of course, you had written them in your notes as 2a. They're using theta here instead of a. You have 3 choices for the cosine, but since you're wanting it to come out to be equal to just sine squared, the logical choice would be to use the last one on that list, because this has only sine in it. Because if you use this one or use this one, I'm not saying it won't still work, it might work, but then you'd have to take care of getting rid of the cosine squared, which would take more work. So I'm going to replace this cosine 2 theta with that last one on the list. So we would have 1 minus, and then 1 minus 2 sine squared theta divided by 2. Distribute your minus sign. So your 1's are going to add out. And then your 2's cancel. So you're left with sine squared, which is exactly what we were looking for. Okay, next. Now, I said a while ago, typically you would start where you see a double angle, but actually on this one, it's going to be easier to start over on this side. So what we're going to do is write this down twice and FOIL it out. So just using some algebra steps here. It's supposed to be cosine. All right, so if I FOIL this out, I'll have sine squared plus 2 times sine times cosine, and then plus cosine squared. So I just went ahead and combined the 2 terms in the middle. You'd have a 1 sine cosine and then another 1 sine cosine, which would combine to give you this. Okay. Now, the next step that you're going to want to take, and well, actually you could do it 2 different ways. You can either substitute here or substitute here using your Pythagorean identity that we had learned previously. And so it doesn't matter which one. I'll just take this one. So I'm going to replace the sine squared with 1 minus cosine squared. I actually don't need the parentheses. And then I'll bring down the plus 2 sine theta cosine theta plus the cosine squared. Okay, so what will happen, see, is your cosine squares are going to add out. Of course, that leaves you with the 1. But this is your double angle identity for sine. See, if you have 2 times sine times cosine, that gives you your double angle identity for sine, so you can replace this with sine 2 theta. And of course that's what we're looking for there. Okay, next. Okay, on this one, I'm going to work on this side. That's where my double angle is. Now, I didn't give you cotangent, but as you saw earlier, you can use tangent. You would just need to flip it. So if you'll go back and look at your double angle identity for tangent, but when I write it down, I'm going to go ahead and do the reciprocal, and we'll flip it. So I'd have 1 minus tangent squared on the top, and on the bottom, I would have 2 tangent x. Okay, so first of all, your 2's are going to cancel each other out. And then what you would want to do here with what's left is split it up. so do your first term over your denominator, second term over your denominator. So that would be 1 over tangent x minus tangent squared over tangent. Now 1 over tangent is cotangent. That's just your reciprocal identity. Of course, here you can reduce. You've got 2 of the tangents on the top, 1 on the bottom. So this one will cancel one of those out and then just leave you with the tangent x. So there's that one. All right, last one. Okay. On this one, I'm going to work on this side. Like I said, most of the time you do go wherever you have a double angle, but you saw that one example that didn't work out that way. So just keep that in mind. Okay, you've got 3 choices for your double angle for cosine. So what I'm trying to come up with, of course, this is sine, this being cosecant, but cosecant is the reciprocal of sine. So your logical choice to use here is going to be the double angle identity that it has only sine in it. So I'm going to replace this with 1 minus 2 sine squared theta. And then that's over sine. And then at this point, split it up. So do the first term over your denominator. And then the second term over the denominator. And 1 over sine is cosecant. That's your reciprocal identity. And the sine that's on the bottom will cancel with one of these. So that will leave minus. So that will leave you with 2 sine theta, which is what we're looking for.